I've seen a lot of pre-calculus, calculus AB, and calculus BC students get a lot of sudden struggling with their courses as soon as inverse trigonometric functions start becoming relevant. So I'm going to quickly explain how you just understand it, so that when you get faced with inverse trigonometric functions, you can just understand it instead of copying the methodology that other people are using. So when we have sine of theta, we know that that is telling us, based off of an input of an angle, what the ratio of the opposite side of that angle to the hypotenuse is. In other words, if we have a right triangle, and this is theta, this is the opposite side, and this is the hypotenuse. Arcsine is the inverse of that. Instead of putting in an angle, what we know and what we have is the ratio of the opposite over the hypotenuse. So opposite over hypotenuse is equal to square root 2x, and don't be intimidated by the fact that this isn't a fraction, because we just divide it by 1, and then we have the hypotenuse is 1, and the opposite side is square root of 2x. And it doesn't matter that we don't know the angle, because we can solve this without ever knowing the angle. We could solve for the angle, but why do more work, right? 2x, 1. Now, using Pythagorean theorem, we're able to solve for this side v. We have 1 squared is equal to square root of x squared plus v squared, and that becomes 1 minus 2x square rooted is equal to v. Let's go ahead and put that in. Square root 1 minus 2x. Now, this is the part where you have to understand where the trigonometric function works. If you don't understand that, then you're going to have a lot of trouble really parsing how to do these questions. We can't solve arcsine square root of 2x equals arccosine square root of x, unless you use like a calculator. Even then, I don't think my graphing calculator would do that easy. So what we do is we take the sine of both sides, or the cosine of both sides. Get cosine arcsine of square root of 2x is equal to the cosine, the arccosine of square root of x. Now, an important thing to remember here is that the cosine of an arccosine, well, arccosine is telling you you have a ratio here and you want the angle associated to that ratio. And then you're putting that angle into cosine once you finish it to the whole cosine. You're putting in an angle and you're saying, what's the ratio? In other words, this is a function, the cosine, and the inverse function of arccosine, which cancels it out, and it just leaves you with square root of x. Now, arcsine here of square root of 2x is going to be equal to this theta. Once again, we don't need to know what that theta is, because all we're doing is we're taking it and we're plugging it into cosine. So we could rewrite this to be cosine of this theta that we have inside of the triangle. It's equal to square root of x. Cosine is equal to adjacent over hypotenuse, which becomes square root of 1 minus 2x divided by 1 is equal to square root of x. Now, I'm going to trust the rest of you to be able to do the rest of this algebra. You just square both sides and you solve for x. The most important part here is understanding the relationship between arccosine and cosine. Understanding the relationship between an arc trigonometric function inside of a trigonometric function means you don't need to find the angle. You just need to understand the right triangle that is hypothetically existing in this scenario. This is really important for calculus BC when we start talking about taking an integral of a very complicated function. The only way to solve this integral is an understanding of inverse trigonometric functions.